In yesterday's class, we have discussed on few things. So primarily into the string formatting and assignments and others. If I say like git status, you can see the list of changes which were done. So what are the changes were done that I need to push, right? So to push the changes, so I need to first add these files. For that, you say like, git add, I need to select the file. So if you do a right click, it will select. And again, if you do a right click, it will paste. So git add that particular files. So there are other ways of doing also, but I don't want to tell that at this stage. Explicitly, what are the files you have added? You need to just, select, paste like this. Now, if I do a git status, see all the files were staged. So these files I need to push. So git commit -m class 09. So in class 09, what we have done? So that information we can write. Class 09, say I worked on string formatting, Unicode characters, and byte array. These were the various things I did. So then I need to do a git push. Git push origin. So to which branch I am doing, to that branch I need to push. Now finally all the code was gone. If I again now go to your GitHub again, so my repository, in that repository I can see all these changes. If you see now the repository, this is my repository. What are all my repositories? You can see in the left side. So it's like a typical Facebook page where everyone's repositories you can see and others like that. So you can see that your code repository is there. In this repository, you can work on whatever you need. Say, if I see the code tab, in the code tab, I can notice that, what are changes were done. Just now I pushed these changes. I need to compare. So means like for every time when you're writing code, you need to write in your branch and you need to push. So what are the changes I am pushing? They're coming here. So class name. So if you want to add some comments that, okay, this is related to the string formatting. So Unicode strings and byte array. So this is what and you give a pull request. Means you are telling that, hey, from this class 9 to main, you accept. For that, you are asking to pull the request. So generally, there will be reviewers who will review and they will accept it. So once at this moment in this project, there is no reviewers. Directly, you do a merge. When you're doing a merge also, you can write some comments. So why you are merging, for what reasons. So after doing a merge, your all code will be there. Now, if you see the latest code, by default, all the branches will come. All the branches will be there, the 9 branches, and apart from the main branch. And in the main branch right now, what are the code you have pushed was gone 2 minutes ago. So this is how the same cycle we need to repeat every day. Now we need to create one more branch. How do you create a new branch? So we can create in a UI also, but I would recommend you to create every day a new branch for every class. So today is class 10. So I can say like git checkout -b. As you are creating a new branch for the first time, you need to do -b. Afterwards, when you're doing a checkout, means when you're switching from one branch to another, this -b is not needed. This -b is needed only for the first time. So if I do like class 10, now if you see git branch again, so it will have locally, means within this pod, these many branches are there. In that, we are going for the 10th branch. So today, whatever we do, everything I will place here. Now coming to our course content. So what we have done earlier, so we worked on like byte strings and other kinds of string operations. So, okay, we want to know about today. We have seen about the Unicodes also, but I want to now focus on byte strings, byte strings, and like string immutability. These 3 concepts I want to do. So first and foremost, as I want to focus on the string immutability dot ipynb. So first I want to focus on string immutability. I didn't create a .py file. I created a ipynb file, means a Jupyter notebook. When you create the moment, first we need to start a kernel. So, and then we need to specify. So I am saying the concept of immutability. What is immutable? Any object is called as immutable when you cannot do the in-place changes. If some objects doesn't support, so strings are immutable, means doesn't support in-place changes. In-place changes. What do you mean by in-place changes? Means you can notice here. So in-place changes means any object when you have, it should do some kind of operations we can perform. But if the operations that you're trying to perform are doing in place or not, that we need to observe. Means let's say I created a small thing. Say name is equal to Gudo one resume. So I created a name called as Gudo one resume. He's the creator of Python, and I am asking, hey, what is the name? So it's a string. So we know that it's a string. If you want, you can ask the type also. It can get. So now the point is, I want to do some change. Instead of Gudo one resume, I want to say like Gudo one Rustum. How do I make? So means if I want to get specifically this particular point, Rustum, then I need to give the address locations. Means let's say if I say a particular value, take an index, say some 5. If I take a 6, 5, 1, I'm getting. So maybe like just a V we got. Maybe instead of a Gudo one resume, Gudo bond resume I want to make. So this fifth character I want to update, say B. One character I took, that one character I want to update. What is saying? String doesn't support item assignment. Means you are not able to do. So similarly, good of one, right? So one, if you want to get, how you need to do? So from fifth position, plus 5 plus, this is 5 means 5, 6, 7. Next 8 also we need to do. Because if you want, you should go till the next value. So we need to give plus 1. So we cannot take a particular character and replace, but at least let me try, like this. Means we cannot take a individual character and replace, whereas you cannot take a particular thing and do. Sir, you may ask me, we are able to do the things in the other way also, right, sir? We are doing replace. Hope you remember, we have the replace. If I do V, I want to replace with a, B, we are able to do, right? Why we cannot do that, sir? Why you are saying we cannot do? There is a difference between this operation and this operation. The reason I'm saying, what are the changes you do here will not change the original object. After doing these changes, if you ask the original object, again it will be good one resume only. If I do dot replace, dot upper, so and so, it will be the different. So whether you are able to do on the same object or not. To understand furthermore, there is some, for any variable I told, right? So there will be in object-oriented programming, there will be three things. One is the value, the other one is the type, and other one is the address location where it is stored. Just imagine I have given rice bag. As it is a rice bag, you know how much size it gonna have. So based upon that, you will store in a particular container. You will not store in a a small rack, right? Rice bag means. So if I give like a pendle or something, you will not store in a big almirah. So based upon the size and the thing, so you take a particular thing. So how that's the reason in the backend also it will happen. If you want a value, you get the value. Okay, what is the value? Sorry, name, right? Name is the value. And if you want to get the type, we have type is another built-in function. And if you want to get the address location of any object, there is something called as the ID. If I give these three, you can see the three things. So why I told this point? Very simple. So we know that we cannot in place changes will be done. Whereas, sir, we can do this kind of, replace also, right? Let me try that. If you do like this, it will not change the original object. But we can also do like this, right? After doing these things, can I ask these three values again together? Maybe I'll place all of them together in one place. You see, I'm asking all came one place. I am doing like a in-place changes. And after doing the in-place changes, so I want to ask, hey, what's the value? You see, instead of good of one resume, it became good of one resume. But did you see the address location was changed? Means when you are overwriting something, so the address value will change. Also, instead of replace, we can also do in the other way also, right? So what else I can do? I want like only the fifth character to be changed. So till fifth character, I get it. So, but like instead of a V, I write a V. And from sixth character onwards, I take it. Hope you know, right? Like this also I can do. Replace. So like this smartly I can do. Like this also I can do. But every time when I'm making changes, I am doing like a in-place changes means overwriting. So you cannot do in-place changes automatically, but this kind of overwriting is happening. So that's why this concept is called as overwriting. Every language supports this. Why I'm telling that this is not in place? Because the address location is changing, right? This is what you need to be aware of. This is a very, very important concept called as immutability. Python supports this concept of immutability. So, and there are other data types also which support this concept of immutability. So, where this is one thing to be noticed. Next, going further, like this one, we can notice on the next one called as GH. Next, I will tell something called as byte arrays and byte strings. What is this concept of byte arrays and byte strings? When we need it. Generally, down the line, you will learn about different file systems. What are the different file systems? Say like you have images, you have like videos, you have like a something. So these are all like binary data. So if it is a CSV file, it's a simple thing. Text file, it's a simple thing. But in real time, a lot of data will be binary in nature. Why, sir, binary means? Just imagine if you have an image. How an image is stored? Image is stored in terms of bits, right? Zeros and ones. So it's a binary data. So when you're all this binary data we need to process. For that, you need to understand what are these bytes and byte arrays. So before going to the bytes, I'm telling byte arrays. So till now we have seen strings are immutable. That's great. So whereas byte array, this is very interesting. Before even going to there, so what is this byte array? I want to understand. In Python, if you, especially when you are in the Jupyter environment, if you want to get the help, you can write a question mark and type byte array. In fact, there is a built-in function called as byte array. So if you do that, it will give the help. You can, if you are in an ordinary Python so script mode, you write help built-in function. Whereas here, you can write a question mark also. So it can help you. Sorry, like this, sorry. After writing something, write a question mark. So then it will say that, hey, byte array is a built-in function. It will take what are the iterables of integers. Or like you can give a string and you can give encoding. Or you can give a bytes or buffers and it can give. Or you can give an integer or simply also you can give. So this is what is this function doing. Okay, what it does, let's see. First, if you want to create a empty, byte array, there is something called as like this. If I just do byte array, I am not doing anything. It created an empty byte array. Okay, so let me assign this to some variable. Okay, so value is equal to, so byte array like this. So the same logic what we done earlier, for every object, you want to get the value, type, and address location, right? So let me use the same concept here. So here I called as a value, right? So value, and here also value. If I ask, it is saying it's a byte array string. So, and it has some address location. Everything has an address location. But if you want to create some byte array with some values, empty byte array you created like this. But if I create like this, for the byte array, if I pass an integer, it will create a byte array of those many bytes. And /x means hexadecimal representation. Everything zeros. Means it's a empty string like that you can think. 8 positions are there, sorry, 10 positions are there. Everything will be like this. So what is the usage I will tell shortly. But like if you see in this example, you are creating a byte array string with range of 10. Range is a built-in function I told earlier, but again I will discuss again afterwards. If you give some sequence of values, if you want to generate, you can do it. It also will generate same like that. Or if you have like a ordinary string, and if you want to convert to a byte array string, say byte array string of, say, I have hi. Hi is a string I have, but it's saying what? Hey, string argument without an encoding. I cannot take a string directly. So if I need to take a string, so I need to pass what is the encoding. So apart from string, there is another option called as encoding. This encoding I need to specify. Now this is a concept I told earlier also. That's the reason I told encoding concept. Encoding means what? For every number to store or like to transfer, so everyone need to understand. Means your keyboard, when you're typing like a any key, how it is understanding? There is a common number to it, right? Or like when you're transferring from your computer to my computer, so how my Facebook chat is reading that? Because every character is recognized by particular character, particular number, sorry. That is called as encoding. So this encoding is pretty much needed for every data, whether you store or whether you transfer. So here I wrote like a hi, but you don't know what is this encoding. So what are the different encodings? ASCII is there. So I am telling that this is a typical hi, right? All English characters. That's the reason I told it's a hi, it is an ASCII. Similarly, if I tell like, hey, it is a UTF. So you may not remember much things. So ASCII, UTF-8 are the most common things people use. So whenever needed, I will tell the others also. I am saying that it is a UTF-8. Then it will take it like a byte string. So, or like whenever you have a non-English characters, maybe like, so some Greek characters I will take. So I will take like, some Greek characters and I try to do something I want to do. So I will take some of them and I gonna work on them. So same byte array of, I write like these Greek characters. Okay. And if I give like encoding, this encoding, if I say ASCII means only English characters. English or anything on your English keyboard. But it is saying error, right? Because they were not English, it will not accept. So we should be, so this much you learn, that's it as a beginner. UTF-8 if I give, then it will accept. Hope you understood how it is reacting to both the things. Similarly, so with this, we can also generate, so in the other way also, means you can give like a byte array. Byte array is like, one more thing. Yeah. So byte array is like a function till now. Like that, we can have like, from hexadecimal. If you have a hexadecimal values, from that also we can create. Or so if you have a byte array string, so that you can convert to hexadecimal also. If you see in this case, I have taken some binary data. So whatever is. So if I prepared by B, it is like a byte string. So like that also I can create. So like this, different kinds of strings I can create. Now, what is the point of going for this byte array string? Generally, when you go with binary data, and if you want to process it, so either you go for byte array string or byte string. And compared to an ordinary string, this byte array string is slightly different. Let me take the same example. Say the same name we have earlier. So what is the name you have? Gudavan Rusum, right? The same name I will take here again. So same Gudavan Rusum I want to take in the byte array string. Ordinary I define it. If I define, and like if I ask, hey, give me the name, type of name, and address location of name. This is what we ask every time. It's an ordinary string. Whereas if you define the same string as a byte array string, so what will happen? You pass like byte array on coinso, and if you ask, what is saying, hey, I need a encoding. So either you give an encoding or place a b before it, but fine. So if I say like encoding is equal to, as it is all ASCII, I gave it. Now it worked. Now what is the advantage of this byte array strings means? We can do in-place changes. Means if I want to change, if I want to do like ordinary string, here also I can do indexing. If I ask fifth position, instead of giving like earlier fifth position means it gave like a van, right? Whereas it is gives 86. What is this 86 means? Hope you remember yesterday I told there is something called as ORD and CHR. If I do CHR of this 86, CHR is a built-in function. If you give any number, it will give the corresponding character for it. So like that, actually if you give any string, it will first convert to their ASCII codes and it will store like that. Means if I go to each of the value, it will do like that only. So whereas if I ask for a slice, like an ordinary string, if I ask here also, if I ask a slice, but it will give like this byte string. Individual characters, it will do like this. Now I can change based upon the position and like this also. Means if I go for the fifth position and I want to replace with B, as it is a byte string, you need to process everything in the bytes place only. So as you don't know bytes, you write a B before it. Any string, if you place a B before it, it becomes a byte string. You cannot do a direct operation, but if you want to do, you need to do like this. If I do like a B, I can do what thing? Byte string cannot be interpreted as an integer. Hmm? Okay, so it is saying what? I cannot take it. So that's byte. 1 second. Yes. What is this happening is that whenever you give an individual character, it don't know like it to take an ordinary character. Whereas ORD means what? You will get its number actually. For every character, it's Unicode number we will get that you paste. And now if I ask, hey, what is the name? You can notice that Gudo Rusum came. So this is how you do operations on a byte arrays. And similarly, if I say a name of, say same thing. So what is that? 5 to 8. If I ask, I got like, Gudo Bam, right? So I want to say like, some can I want to replace. So I want to replace with some can resume. So it is saying like I cannot do like this. So as we know, so we need to pass like either a bytes or a buffers or a iterables of strings. Either of these things you can give. So if I give like a b before it, byte string, so then it will take. So now if I say name, you can see it. So this is how we use it. This is a byte array string. Now the last point we have is about the byte string. Same like the byte array string, slight complicated. So generally at this stage you may think like this is too much, but in real time at this stage you will not use. But in real time when you're working, bytes strings are most commonly used. So like byte array, there is another thing called as byte string. So every time I'm making a b before it, right, it becomes a byte string. So if I go one step ahead, I byte string dot ipynb again. Whenever we are explaining a concept, it's better to go for a IPython notebook. When are you doing a real-time example, we can go for a py file. Byte string. In this byte string, what we can learn? Okay, so byte string means, like as I told, uh, generally when you have any string, when you define represent directly, we have like a so my string and its type, if you ask, it's an ordinary string. Whereas if the my string, if you define in a byte array, we need to pass the encoding, right? We know encoding, as it seems like all are English, I can give like this. You get a byte array string. Similarly, if you define the same string without a byte array, there is something called as a bytes. If I define bytes, you got like a byte string. So this is another kind of string. So mostly you work with byte string only. Byte strings, all the binary data we get, it will be in the binary form. This byte array is for like operations on this binary data. So mostly you work with this byte string only. So whenever you open an image or anything, everything is so and so. If I say, like, binary files, if you ask, you can say everything is a binary file. So binary file examples, if you see, so everything whatever you see is a binary file. So is it a text? So images, or like, what are the things? What are you see mostly in real time were all binary data. So binary data will have same operations like our ordinary string. If I say the dir of an ordinary string, and here you can notice the difference. I think byte array we can ignore, but like if I say the initial ordinary string, if I say here itself, there is a built-in function called as dir. If I give the dir, you can see the list of attributes. And if I do a print of it, you can see all in one line. And in the same fashion, I can take a byte array string or a byte string, and here also I can ask to print. And if you can notice the first line and the last line, you can notice some differences. So in an ordinary string, we have seen already all these things: partition, splits, all these things. In the same fashion, here also we have everything is there. So whatever you see in ordinary string, byte array string also will have. There is no difference at all. But the only difference is we need to work with all these things. So let me do a couple of operations. What we did in a typical, attributes, string attributes. You remember we worked on the string attributes. The same rules we can work here also. For us as to understand a bit, we can take the same examples and work. Say like where we can find. Say you have a find language and a find is there. So that kind of examples, if I say your string is my string, right? If I print, it's a byte string, you got it. In this thing, if you do like a find, if I want to find Python, I cannot do just Python. I need to place a ordinary string. I cannot do. I need to place a b. That's it. All operations you need to place a b before it. So if I want to do this thing, dot upper dot lower, that is okay. Dot upper dot lower, these kind of conversions are okay. But if you want to, every time you get like byte string only you are getting, right? So similarly, so my string dot is upper, like that you can ask. So that are operations. But whenever you performing like find or like replace, say you have like my string, so dot replace. If you want to replace, Python is interesting. So instead of Python, I want to replace with Django. Django, if I say, it will not work because all the values should be like type B. If I write a B, then it will work. Same operations. As just you are when you are working with binary strings, just be aware. So most of the people, when they're working, they do like B for everything, or first convert that binary string to ordinary string. That's it. Either way we can do. So that is possible. And also, if you see, like, there is something called as in decode. As it is a binary string, if I say decode, it is decoding to ordinary thing. Means byte string to ASCII string. Means ordinary string. I'm saying. Did you see when I did decode, it happened? Now, from now, understand this concept. Encode, decode. In which case we need to use. Most of the people don't know when to use. They just randomly do encode, they do, then they do decode and all these things. Just as you will be working in real time a lot with these things, I am giving you this example. And similarly, how we have done for this one. So here also you need to understand. And the most commonly four kinds of formattings you will see encodings. ASCII I told, like UTF-8, UTF-16 pointer means furthermore big. And the other one is called a CP232. Generally, Windows, if you are using, you will use this for this encoding. So these were like the most common four encoding Unicode formats. And for this conversion, I told, like, if you have this string, if you want to convert to an ordinary, you do like this, right? In the same fashion, we also can use ordinary built-in function called as str. If you use str also, we can convert. But did you see, when you're doing an str, even B is also coming to be part of it. So that's the difference between this. That's the reason when you have a binary string and if you're converting to ordinary, along with that, you need to pass the encoding. So encoding plays a very crucial role. So if I place the encoding is like, say, ASCII, in this case, all are like this thing, then it will work. Hope you understood these three differences. Whenever you want to convert from it or convert to back it. So this is how. And similarly, like how we created a bytearray string. So like that also we can convert. If you have an ordinary string and if you want to convert this encoding, so this is how you do. If I say like this, it will convert. So if I give like any encoding, it can do. The second option is encoding only. If you give explicitly encoding equal to or not, the same thing works. So, but like if you have a non-English characters, ensure to pass a UTF-8. So that's what I took a couple of Greek characters and I can do. So like this. So we can touch base again. So, okay. In byte strings, not only this. So as I had discussed earlier, we can work on the different kinds of other things also. Means like on a ordinary string, when you do like a operation, you do like this. So a dot replace or whatever might be. Whereas in a byte string, so we do everything with bytes only. Byte strings and byte array strings. So every time you need to prepend with a B. That's the main thing. Or if you want to do anything like any operations, you see here, for everything, you want to check for a in. So check for a particular string which is present in or not. Like a left strip, R strip, or you want to do any operation, just prepend a B, that's it. Or similarly, if you want to do the split operations or whatnot, for every operations, you need to prepend a B. So whatever all the operations, it need to follow in the same fashion. Even string formatting, placeholder replacements, or whatnot. This is all about the byte strings and byte array strings. Okay. Next, the last point here is about IG string module. Till now, I am telling the operations, how things are working. I can say I seldom worked on the modules till now. So one of the modules, which is there built in, the moment you install Python, we get something called a string. So modules are something which will come by default when you install Python, and some we can install also. So, and any module, if you want to use it, first we need to load it. So for loading, we need to do this import statement. So say once loaded, it is same like a object. Like how you define a variable and you have its all the things. Here also, you will have everything. If you want to get the values, I told right, every object will have three things called as value. And if you want the type, we have like address. So, sorry, type means like ID, right? Sorry, type. Type is a built-in function to get the data type. And similarly, ID will be the address location where it is stored. For every object, these three will be there. And apart from this, there is one more thing also, right? Like address, usage. For that, we have dir. Any object, whether you create a variable or you import, so everything will have a usage. That's the reason Python is called as a object-oriented programming language. Everything is treated as an object. If you see, did you see where it is located? Under your where Python is located, there is a lib folder. In that, there is a py file. Means every module that you are working, in fact, it's again a .py file. Someone has written all these things together. In fact, we also can create our own. I will take you to that stage someday. And if you ask the type, it says it's of type module. It has some address location and it has a lot of things to do. So if you remove the things which have underscores on either side, even then also you have a lot of things like ASCII letters and all these things. Generally, when you work with these ASCII values or like anything in string, say like sometimes when you are working with strings, hey, check the character is any of the alphabets, or you want to get only small alphabets, upper capital alphabets or lower alphabets. So like that, if you want, it has everything ready made. If you want digits, you want white spaces, everything are there. So whenever you want these characters, instead of you writing manually, you can say like strings dot digits. So you'll get all the numbers. So strings dot octal numbers, strings dot punctuations, strings dot printable characters. So white spaces. So like that, everything they have written ready-made. So whenever we need, we can just use it. In the same fashion, they have some few operations also, but seldom people use those operations. Mostly the string module is used for this kind of ready-made placing of everything together. But it also has some operations here and there, like cap words and others. But people don't use that because if let's say take the example of cap words, if you give any word, it will try to do the capitalize. You know, we have a string dot title, right? For doing the same thing. So for every word, first letter capital means, for that we can have a string dot title. As it is a repetitive, people don't use much, but only for this main purpose, people use it. And similarly, to prove that, I have written like separately. See here, if I have an ordinary string, if I want to capitalize, so means like, sorry, title case. So if I do cap word or like this also, both will do the same job. As it is a repetitive, people don't use it much. But there is one more operation which people use some way. That is called as a template. So this module is used for like these values, and second one is template. What is this concept of templating? Say you create any string, within that you define something like a dollar. So till now, you know, old style formatting, new style formatting, F strings, F string assignments, I told all of them. So this is another kind of thing where if you define something like this template, by default, nothing will happen. But for this template, if I substitute something, then I will get that output. Means if I do a substitute of name is equal to world, means wherever this label called as name is present, it will replace. If I just place a name, it will not do. I need to say hello name so and so. So similarly, so you can write any template and you can replace with anything else. Say this time I write a complex template. Say I have written a template. You say I have name is also there, dollar name is there, $2 name is there, $3 name is there, and I have age. Like that, I created a template. Now I need to substitute something, right? So I need to have substitution. Now, how many placeholders are there here? If you observe, dollar name is also there, dollar age is also there. Two things are needed. But after defining this template, So if I do like, t dot substitute of name is equal to world, same like above, then it will throw an error. The reason being, hey, I don't have the second one called as age. You have given this one, so you need to pass both of them together. Means if I give now both the things, for age also if I pass, name also if I pass, now you see what will happen. So whenever I have a name as it is, it came. So for the same name, there should be a dollar before it. Then only it recognizes like a very label and it will replace with the word. Similarly, $2 I have. So $1 it will be like that. And the second dollar it will recognize. So that's why you got like dollar world here. Similarly, age. Age is so equal to dollar in flower braces age years. Means if generally you write like this, then it should treat what? It should like age years. But as you had defined like this, it will treat only the part which you have given like that. But okay, so we have much better things right now with a f strings, right? That's the reason these days people are not, doing that much. So one conclusion I want to make a note is that whenever like you have $2, one of the dollar will be substituted. So that's the reason when you have like $3, so you got $1, right? Whenever you get like $3, you got $1. Means for every $2, you get $1. Or like if you want some identifier, this is how you do it. So like this. So or like let me write both the things together in one shot. I wrote a template and also substitute also in same line, just for you to understand. So wherever the dollars are there, it will just replace it. Or like if I have, so see here, in this case, substitute. So in this template substitute, I have like this define two. But in this case, I have who is there, what is there. Two things are there. But in substitute, I give only one. Earlier, when I gave like individually name is equal to like that, when one of them I didn't give, it throw a key error. But in this case, will it throw a key error? Definitely. So whenever something is not there, it will throw a key error. But if you give both of them, then so it will get the both of them. If I say like who I give and also like what if I give, then it will work. Say Python something, you're gonna get it. So same logic, whatever you do, it will work. Okay. So okay, yeah, sorry. And one more thing, there is one more thing called a safe substitute. The safe substitute, what it happens is like when you give both values also fine, but if you don't give one of them also, it will work. You see, safe substitute. So this is one thing. As this is one of the operation I'm telling, but this is not that much needed. This kind of templating. But the next important thing that we'll focus now is on the most important point in every language. That is called as the language component. Every language, if you want to get Excel, you will know the basic grammar. So this is kind of the basic grammar to the language. So it means every language when you're learning, the first and foremost thing you do is like first after defining variables. Till this stage, you know how to define a variable, how to work with integer strings like that. Now how to do operations between them, that's where you will learn here. When you have two or more variables, first we need to relate them. That's the reason we have something called as relational operations. So if I can take within that, relational ops dot ipynb. What is this relational operations? How it can help us? So generally in relational operations, every language has this concept. It's not nothing new for us. If I say in this case, you will notice in every language when you have two things, you can relate them with a less than a symbol, greater than, less than or equal to, like all these symbols. But whenever you do all these things, if the relation what you mentioned is correct, it will say true. If not, it will say false. So let me take a simple example. Let me take two things. Like, US dollar is like 81. So Canadian dollar is like, so 50 something. I think I was somewhere at like, 86 something now. if there are two variables, and if I'm asking to print the variables, just it will print the values, right? Whatever the value is there, it will just print it. Fine. Now, if I want to do the things in a much better way, that's where we have f strings and f string assignments. Hope you remember. To avoid this kind of repetition only, we have like f strings, and to make the things much more smart only, we have like f string assignments. Hope you remember. The same thing will be repeated. So f string assignments with less code, we can do much better things. As we came to the context, I'm telling. So similarly, but like if you want to compare two things and if you want to see the difference, I want to show you here. I am saying this, why I'm doing this quotes, the highlighted part, in the output I want to see. This is the actual evaluation I'm doing. Is US dollar equivalent to Canadian dollar? No, because values are different. So though as you made equal to, it will say false. So I got the previous statement and the next statement. But if I want to get all of them in one shot, I can write the same statement like a F string, right? F string assignment. F string assignment means what? Whatever the logic you want to write, you write inside within the flower braces. At the end, you give the equal to symbol. If you give that, then you get the same thing. See, with less code, I showed everything, right? And if I need to do the same operations for others also, I can do all of them. Means if I have two variables, they have some value, I need to evaluate whether something is correct or not. I give all the relations. If any of the relations are correct, it will say true. It doesn't mean that only one should be true or one should be false, depending upon the logic. So greater than or greater than or equal to, both are true. So not equal to, that is also true. So less than or equal to, these two are false. And for this less than or equal to, there used to be one more symbol called as, like this operation. This used to be a not equal to symbol, but it used to be in Python 2 actually, 2.x. So now in Python 3, this is no more a symbol. Even if you see right now in SQL, you can see, but slowly the new languages, they are ignoring that symbol. So like that, you define two variables and you are evaluating this relationship. In the same lines, I can do the same operation on a direct values also. I can take two numbers and check whether both are, less than or equal to, or so whatsoever maybe. And the beauty is that you need to understand. So whenever, as a beginner, when you're coming, the most common gotcha means like, the common mistake the people do is that. So you need to understand the difference between these two symbols. If I have two equals, I am checking value level equivalence check, whether left side hand side and right hand side both are equal or not. Whereas if I do one equal, that is an assignment operator. So how it actually works, if I have two equals, say I can have a, number is equal to some 34, and I can say like, number 1 is equal to 34. So now you see here, this is a assignment, right? And whereas this is what? So value check, right? Value check. So both has a different significance. It will assign a value, it will check a value. The second one will say true or false. Whereas in the second case, in the value level equivalence, I can check like, number is equal to so and so, or 34 is equal to number 1. Like this also I can do. So in all the ways I can do, right? Number 1 equivalent to 34, or 34 equivalent to number, or 34 equivalent to some 34. Like this I can do. 34 equivalent to some 64. I can do all the 4 ways. So this is possible. Whereas for the assignment, we should ensure that the left hand side should be a variable. So either you assign like this, or you can say like, number 2 is equal to number 1, as we have defined number 1. These two are possible. But can I do like 34 is equal to number 2? I cannot do the third one, right? That is what you should be understanding. The difference between these two. Hope it's clear. So fine, this is how it works. This is a relation operations. And this beauty of in Python is that this relation is not just pertain to one. This relation can be going for multiple things. Means if I say like 12 is less than 34, good. If I say like 12 is less than 34 is less than 54, so that is also possible. Python isn't such a language that you can have like crazily you give any number of things, but ensure that everything should be perfect. If at least one of them is not correct, then it gonna doesn't work. Means like if I make one of them is 167, means if one of them is failed, everything is failed, right? That's what you should be aware. So we will come back again how it is actually doing these kind of the operations in the backend. To understand that a bit, I will tell you there is another thing called as like relational operations. The second one is logical operations. Every language when you're learning, if you learn in this way structure, you will definitely, I'm saying that you will not forget anything. So that's how about it. Into the, this one, logical operations, if I say logical ops dot ipyn. So first I need to select the kernel. I selected and coming to the logical operations. See, any language when you learn, first you relate. After relating, you need to make some logic. So what is that logic? It can be like a end or not. Every language, same concept works. No matter which the recent language like Go language or old language like C, C++, same logic. So how it actually work? Every language has this end symbol or symbol given in different ways. In some language, there is an ampersand for an end, and like some language, it is like a or like that. Whereas here we have a pure English. And those symbols, as I just showed, were for like bitwise operations. I will show you afterwards. So it's very English-like language, so very easy. So first I'm saying about the end operation. How the end operation works means, see, when I did previously the relational operations, you saw that for every relation, when you give, it is giving true or false. So on these end results, we are working. Means again, I will show you why I'm using these things. But at the skeleton, I'm telling, if all the values are true, the result will be true. So for a typical addition, sorry, end operation. If I go for a OR operation, if all were like false, only then it will be false. In all other case, it is swing. Means like R is an optimistic guy, and is a pessimistic guy. So I can think like that. Whereas if you go for a not means it will negate the previous value. So I gave nots in such a way that you can observe clearly. If I give one not of true means I got false. Not of false means I got true. But if I get not true, two nots if I give, it will give the same value. So means like if I give three nots, yeah. Even numbers, if I give even number of nots, you can give any number of nots for that matter. If I say not, false, any number of nots. So it's for like playing, I'm just saying. But like if you give any number of nots, so it will give it. So for even numbers, it will not make no difference. For odd numbers, it will negate. Fine. But what is this true false story? In real world, do you really work with them? No. In real world, you will work with something like this. A real world example like this. So I have an expression. What is this expression actually? It is telling that, you can do something. So in this expression, I have 45 less than or equal to 45 and 3 so and so. Now, first, when you're doing, there are two parts here. There is a relation, there is a logic. First relation, first relational operations, ops, and then logical operations. This is the same logic every time, logical ops. If I do like this, then first what will happen? Relational operation means what? 45 less than or equal to 45. 45 is not less than 45, but equal to. So as any one of them is correct, it will say true. And or as 3 is greater than 333. Is 3 greater than 333? No. So it is a false. And you know how the OR operation works? If at least one of them is true, the result is true. So for R to be false, everything should be false. So as one of them is true, the result is true. Right? And now if I ask, hey, what is this expression 2? You can notice the same answer. Did you see it is true? So similarly, now I want you to tell one of these answers. So who will volunteer for it? Arvind? Pravina, sorry. So please go ahead. 45 less than or equal to 45?
45 is equal to 45.
Yes. One of them is true. So
True.
the result is true. Or now
False.
false. And is it
9
both equal?
equal to 9.
Yes, of course, right? True.
Yeah, true.
No, but there is one complication here. You have OR operations and AND operations. Which one happens first? Now this concept of again the operator precedence comes. Hope you remember? We have
Yeah.
learned. If I go back to what we have learned in the operator precedence in arithmetic operations, I gave one sheet to you. I told that if you have small things, PEMDAS is fine. But you go in detail, you have a lot of operations I told. At that time, I told that you have like addition, subtraction, multiplication, so bitwise operations and binary operations and additions. At this itself, I told that we have like every time, so bitwise or anything, AND operations comes first. You know, AND comes first, then OR operation comes. So first the AND will work. To understand more about it, we can see like this. So within these two,
Yeah.
first it will operate on these two.
Yes.
AND operation will be true if all were true. If at least one of them is true, false,
False.
result is false.
True or false.
Okay. Now OR operation means
Then true.
at least one of them is true, the result is true.
Yeah.
If I ask now, hey, print what is the value of this expression 3, it will be true. So,
Yeah.
but like, sir, who will use these things? I will tell you shortly afterwards. But let's see. This time I give a brace extra. Whenever I give a parenthesis, obviously things within parenthesis will execute first. And now tell me, so is 45 greater than or less than or equal to? Yes. So this is correct. And then you have an OR operation. Is 3 greater than so and so? False. And you have an AND operation. And this is a true. As you know, parenthesis, PEMDAS, parenthesis, whatever is happening, which will execute first. In OR operation, at least one of them is true, result is true.
True.
And you have an AND, other one is true. AND operation, both should be true, then the result is true. Expression 4. You got it? Similarly, if I go for the last thing here, how it will execute. This time I gave everything OR. But you see in this case, what will happen? First one is true, or this is a false, or you have this is a true.
True.
So now which one happens first? Both are OR. If there are two different operators, you can say operator precedence. But here what will happen? Here this is because of PEMDAS. Whereas here because of execution order. Of course, whether anything works, logic will be same. But you should understand the execution order. So top to bottom and left to right. This is how the execution order of Python goes in a Python execution flow. So top to bottom and left to right. So because of this, first it is occurring these two, right? So it will execute like this. So true or false? One of them is true or true. Whichever is true. True. The result is true. So if I ask expression 5, I get the result. No, it's fine. We understood it. So, and now if I go for the complex things, now you can understand why things happen like this. Hope you remember earlier I told multiple relations if are there. How it happens in the backend is, so whenever you have, it will try to do the both. Means if I have two, in the backend what it does, it will do like this. It will take the first relation and the second relation. Why they have taken end? Because both should be good, correct, right? So if it will evaluate both the things. Yes, is 23 less than 73? True. And is 73 less than 45? False.
False.
As like end means like both should be true. If one of them is false, the result is false.
False.
Hope you know now why you got false. So the same thing works even if I go for like a big things like this. Say if a big example, how it actually works. For every number, it gonna do the same operations. Okay. So for every operations for next values, it is doing this one. So next, like that. So, and finally for all values, when it evaluates, so you get some result. And based upon that, you understand. The same thing goes when you go for any complex relation, any multiple relations you can go. So all can be of same relation or multiple relationships. So you can go with this kind of chaining. This is the concept. Now, let me take a small example of something called as shortcutting. It's a very, very interesting concept called as shortcutting, shortcut logic. So, yes. So what is this concept of short circuiting, shortcut logic? Why we need to use? Generally, Python works very smartly. When you big a big operation also, you will understand why it happened like that. Then I will explain. Let's see. If I do like this, 0 and 1, the answer is 0. So whereas I did like, one more operation, say like 3 and 9, I got 9. Then I got like fascinated to understand why it is happening like this. When I did 0 and 1, I got 0. When I got 3 and 9, I got like 9. What could be the reason? So then I decided to further understand why it is happening so and to understand more about it. Then there like, I did one more example. So to try, if I do like this, now tell me what will happen. So 3 and 9 and 13 I gave. Now I got 13. By this itself, now you should need to understand what is happening in the backend. Or one last example I will give. With that, you get a full clarity. If I give like now, say this time, I gave 3 and 13 and 9. Earlier, I gave in an ascending order, but now I didn't give an ascending order. But I gave like 3, 13 and 9. But I am getting 9. So this answer is very simple. You give any numbers, okay? Say 1 and 2 and 3, 3 and 4 and 67 and 3. If I give, I'll get 3 only. Means if all the values are non-zero, the result is the last element. Similarly, if there is one of them is 0, you have 0 at any one place, you get a 0. So what is this concept happening? I will tell you. For now, you can think like, 0 means false, non-zero means true. That's the reason it works like that. So that is how the end is working. If all values are non-zero, the result will be last value. If any one of them is so-and-so, you get the other way. Now let me do one more example. With this, you should understand. You see in this example, what's happening? I did 0 or 1, means I got 1. 3 or 9, I got 3. So 3 or 9 or 13, I got 3. So any numbers I give, so I will get the first non-zero value. I repeat again the same example in one shot where you will understand. So this once you understood, right? Let me move it down. Move down, move down, move down. It's not there. Okay. So you have seen this one. If I give all of them as an positive, means non-zero, you get the last value. But if one of them is a zero somewhere in middle or at the starting, you get the zero. Means for a end operation, all should be true. If any one is false, it will stop there. Means what I'm trying to say, though you have like 100 values, execution stops the moment in the encounter say false, because end operation every time tries to find the false value. The moment at least one of them is false, it will stop the execution. It will not execute the remaining. Similarly, OR operation, if you see, if OR means what? If at least one of them is true, the result is true, right? Hope you remember. OR means what? At least one of them is true, the result is true. In this case, everything is true, right? The first non-zero value it will return. You see, in this example, if I mark as one of them is zero, now I got two, because the first non-zero. If I mark this one also as zero, and this one has some negative value also, doesn't matter. If it is non-zero, it will give. So why I am telling this logic to you? In real time, you will learn a lot about it, this concept. So I will tell you next when you're going for a real-time usage. There I will tell this shortcut usage also. If I tell like this, you can understand, right? So end operation and OR operation, how they are working. End operation means what? Returns zero if any one of them zero. So the first one is zero. It will not even process the remaining values. It will do. But I am showing you the numbers because you can better relate to numbers. But in real time, what will happen? There will be multiple conditions. So it will not check all the conditions. It will check the first condition and stop there itself. Means, say, if a number, say number one is there, number one is equal to some 1, 2, 34. You want to check like, number one is greater than zero, and number one is like, so less than or equal to zero, and number one is not equal to zero. You have three conditions, right? Will it execute the three conditions? So it will check the first condition, whether the first condition is correct or not. Number one is greater than zero, true. And is the number one less than or equal to zero? It is not less. Equal, not, also not. False. The moment it got a false, it will not even execute the last value. That's it. It will give. So you can have like hundreds of logic like this, but it will not execute all of them. The moment it encounters a false, it will stop the execution there. Hope it's clear for you. Did you understand?
Yes.
Now, why I'm telling this is that in real time, this is a very interesting concept, but very few people know about it. I mean, if you don't know also, you write a logic and you just take the output. But you need to understand the background, right? That's why I'm telling this. So the third operations after this logics is about the Boolean. Coming to the case of the Boolean operations, how these Booleans work. Say A. Till now, indirectly, we are working with Booleans only. Means whatever you go with like relational operations or logical operations, both are giving the binary values only, right? 0 or 1. You know about this binary. To understand binary, every language have these binaries. So, but the way they represent is different. Maybe if you go for JavaScript, they say like small true, small false, right? So some other language has something else like that. So like that, here also we can have it. So if I define something, I can just ask, say if I just ask true, as it is a keyword, so it has some meaning, right? So it's automatically coming. And I can ask like, as it's an object, I can ask the address of it. Sir, I didn't define this variable. These variables were already defined the moment it was created. That's the reason it will already have an address location. So the moment Python is up, it will be there. Similarly, if I assign that to a variable and ask, I get the address location. But did you see the address location is same again? If you assign again and again to this another object or new object, so the value won't change. The address location means these are built-in objects. They are like immutable. They will be like that only. So if you can ask any number of times, you can assign to something, but they will be like that. In the same fashion, if you ask something to be like a false, it is also built-in. It is also having some address location like that. So capital TRUE, capital FLSE, you know this one. And these keywords, if you are assigning to some variable, it will throw in error because we cannot use like a ordinary thing. And also, you know the story. If you want to really use something, so you can use a small letters or different case because Python is case sensitive. But it's not a good way. If you want to really use it, you can say like, say true name. You give something meaningful that works better. So, or like, you can assign the same thing to it. If for the same variable called as choice, if I assign this Uday, you see, it is a string and so and so address location. And observe one thing, if I create any variable, my values will be of a different address. Let's say number one is equal to some 123. And if I am asking like address location of number one, did you see what are the user defined variables were in a separate location? Some 1400 something is that? But the built-in objects will be after different address location. That is one more point I want to bring to your notice. As I told you, so Python is an object-oriented programming language. So every object will have a particular address type and so and so. I did like that to understand this much better. So if you want to address location for a small TRU means my variable which I created. So this one address locations comparison I showed. So data types also comparison I showed. But in terms of value, there is one interesting point. Hope you remember I told Boolean is a part of integer. The reason is very simple. If I say like, true, by default it says true only. But if for the true, if I multiply by some number, I get the same number. Means don't you think that true has a value of 1 in the backend? Or if I say like, true plus say 2, I get 3. Means with this 2, you get an understanding that it is having a value of 2 in the backend. Similarly, if I say false into 45, I get 0. Or like if I say false plus 3, I get 3. Means that false has a value of 1 and 0 in the backend. Okay, this is fine. So, okay. And also one more point. If you remember, I told int built-in function. You can apply on a true, you get a 1. So int built-in function on a false, if you apply, you get a 0. Similarly, if I pass like a float built-in function on a true, you get 1.0. Float built-in function, you pass on a true, false, you get like 0.0. But if you apply str, that is different. But this is one of the interview question it was asked. Hey, if I multiply true into 1, will I get a true? This is different. So here, when you do this operation, which will happen first? First multiplication happens or conversion to string? As it is in braces, first multiplication happens. So this true object is very interesting. When arithmetic operations are happening, it will convert to integer. This is the most confusing for beginners, I would say. So many people told it wrong. So when you're going for interviews, this is most important. So any object, so this true or false, if you directly work on them, convert to string, it is converting. But if you do arithmetic operations, that's where things will be different. Hope it's clear between the differences between these two. So if you convert that to a string, that's a different story. If you don't convert, that's different. And similarly, this is what you need to understand. You cannot add like a true plus a 1, because both should be of same type. Like strings, Python is a strictly typed language. All should be of same type. Either convert one of them to string or convert one of them to the others. Like that you can do the operations. So this is the basic booleans. Now the most important part of the boolean. Trust me, so earlier I will give my example. When I used to write in the conditions, when I'm in the starting of my programming experience, I used to struggle a lot. I don't know like how things are happening. I used to confuse when writing if conditions else. But once I came to this bool built-in function, I understood a lot about programming. In fact, this bool built-in function, which I will tell you shortly, you will never use in real time, but it is the logic which is happening in the backend. So the same thing works almost in same all languages. But we are fortunate that in Python we have a function to help us to understand how it actually works. For integers, so be it like, but like integers means int type or like float type. So it will work like this. If you give a zero value, it will be false. So for non-zero, it will be true. Hope you remember earlier I told in shortcutting also same logic, the same thing here. So in this case, whenever the value is like non-zero, you get like true. If it is zero, you get a false. Similarly, the same thing goes for the floating point values also. If the end result, you write like any number of zeros, post decimal, if I have any number of zeros and there is no number, any non-zero, it makes no sense, right? It is ultimately zero. If we have at least one, it is a non-zero. So for non-zeros, it will be true. For like zeros, it will be false. You give positive or negative, that's fine. Similarly, if I go for the next one, if I go for like say string, for string, it will be working like this. For non-empty strings, it will be true. If the string is empty, it will be false. So if you have a single white space, then also it means it's non-empty. Means at least white space character is there. So if you have something or at least white space, it is true. If not, it will be false. So if you understand these logics, it's very simple to understand all the programming. Any object, by seeing itself, you can understand. Based upon the data type, these rules will apply. So if I say a none object, every time it will be false. And if I say a Boolean object, like true or false, if it is true, true, false is false, as it is. Next, you will see the concept of braces. Next, you will learn different data structures. So at the time, you'll understand what is the beauty of a brace. But if you have braces and you have some value, at least one value, it will be true. And if these braces are empty, then it will be false. So like this, for everything, they have given a logic. For logical values, anyhow, when you do a logic, it will give a Boolean value, right? Based upon the Boolean value, you get it. So for everything, they have written logic rules. So in fact, whenever you are working for every data type, the same logic works. Even if I have like a logical operations also, I told you what is this happenings. Logic, this end result, it will get the same thing. So to conclude again, so whenever you have passed different data types, it works differently. So ultimately for every data type, it will check for the empty values or null values. If the empty or null or zero values are there, it will be false. In other case, it will be true. So for numbers, it is not zero is false, non-zero is true. For strings, empty string is false, and a non-empty means at least one character, even white space is a true. Like that, we have all these things. So now based upon these things, we will work in real time. Now let me think of the real time use case. So real time usage, if I take, In the real time usage, if I say, generally, if I have a variable called as a name, name is equal to Uday I wrote. Now I'm checking, hey, what is the boolean of name? For a string, what is the thing? If it is empty or not, it will check. If it is empty, it will be false. If it is non-empty, it will be true. Means, don't you think I am doing the same logic, right? Whether you use bool of name or name not equal to empty, both I am checking the same thing. Similarly, if I have a number, then for a number, what it will check? Whether it is equal to 0 or not, right? That's what it checks in the backend. So in real time, what will actually happen? If you want to do, so you write a logic like this. So explicitly means we write in real time logic like this. I define a variable called as number1. I defined in the top. I am saying that, hey, if number1 is not equal to 0, then print. So this is how you write a condition. It is non-zero. Non-zero. This is how you wrote. But what happens for what are the conditions you wrote? This condition, whatever you wrote, that will be first passed into this one. Bool of this function. This logic will execute. Is number1 not equal to 0 or equal to 0? Relation logic. Yes, it is true. Then it will result like this. Boolean of true. What is Boolean of true? It is a true. So totally this value is true. So then it will go into this. Means why I'm telling all these things, this is the backend story. You will never use the bool function in the backend. But this is what happens. So one more logic people will do is that whenever they want to check any number to be not equal to 0, they don't write like number not equal to 0. They write like this. If it is some other condition like less than 10 or less than 5 or something, they write explicitly. But when they are checking for equal to 0, not equal to 0, they do like this. So whether you do like this also in the backend, the same logic happens. If we just do number also, they do like that. So this is called as implicit condition. Means they don't explicitly write. If number means if number should be not equal to 0. So if or like if I say like this, what do you mean by this? If 1 means every time do this condition. That's what right happens. This condition will happen every time. If I say if 0, it will never happen every time. Hope you know, right? So like this. So if I say like, if not 1, not 0, then it will print every time, right? So whenever you are doing condition, you need to understand. Or say like you have a name. So you have a name. Say I take this value in runtime. So enter name is equal to. So if name, so print name is equal to name, whatever you have given. I execute it. It is asking in the top. I don't write anything, give an enter. I am not getting anything because in runtime I didn't give anything. If I execute again, in the top, if I give something, if I execute, as name is there, which is not equal to 0, it printed. Means when I gave just name, I am indirectly telling that, hey, so check for, so name is not equal to empty string. That's what you're telling to it in the backend. It will happen the same thing for a bool of it. So, and like it is, whether it is correct or not, it will check and you will get the result. If it is true, then you get it. Hope you understood how the story is happening in the backend. The same thing works even if you have a numbers or anything. Say if I take one more example, you see for the numbers also same story, right? See in this case I wrote minus 0.00000. I have any number of zeros, but ultimately after this, is there any one single digit? There is no digit, right? So no number. So you write any number of zeros, finally it is a 0. If you ask number 2 also, it will be 0 only, right? So, okay, as it is 0, then the same thing works. So we can write like multiple conditions for it and to check. So number 2, what are you wrote, is not equal to 0, then it is not equal to 0. Number 2 means for integers, it will check like that. For based upon the data type if you give, so whenever you're doing this kind of explicitly, if you are not mentioning, it will do in the backend. So due to that, what happens is like, so we can do the same thing in different ways. So if I have something, let's say x equal to none. So what I will do generally, if x is none, then print x is default. Like this, I want to write. Means what you do, this is the condition you wrote. Is another operator where you want to check whether both are equal or not, same object or not. So if this is the case, the same thing can also be done in another way. Hope you remember earlier we learned the concept of short circuiting. So it is like XOR default. So this is concept is called as short circuiting, right? So if X is a R value means what? The first so true value it will take. If the X is a none, which is a Boolean of null means false, then it will go to the next value. So like that it will go. Or next, for the same concept, there is one more thing called as ternary operation, which I will tell you shortly. Ternary operation, I will tell you shortly. So that is also possibility. When I go to the conditions, I will tell this. So like this, you can use the built-in bool built-in function for different things. Why I'm telling all these things? Because you should be aware. And like one small funny thing, as we have done very seriously till now. So there is someone wrote in a blog. It's not mine. So there is something about the bull. Someone written a love letter. So using Boolean. So they made use of the built-in concept. So there is one module in Python called as this. There is one module called as this. So every module has one purpose, right? Like this here in Python also the same thing works. Okay, instead of a ordinary Python, I write a IPython Jupyter notebook itself. Then it's easy. So IPYNB. So first I need to select the kernel. I selected. Basically, every module has a purpose. This module also comes with a purpose. See, every module is for some usage. This module will tell the philosophy of Python. The moment you import, it will print all these things. What it is saying, Gen of Python means what is the philosophy they are doing. Whenever they created this one, beautiful is better than ugly. So simple is better than complex. Means whenever you are doing a solution, try to make it as simple as possible. If you write a very complex logic, it may be very good, but it is not maintainable. Say when you are in a project, you are not the only person who develop it. So after you developing, someone else may edit it. So try to write the code as simple as possible. So that's what the philosophy they have. Based upon this, one guy used it and did it. So he did like this. He created a variable called as love and I assigned to this. Now, if I do like love also, the same thing happens, right? Both are same objects. Fine. Now, based upon these things, he did like some kind of things. If I'm doing like love is equal to this is equal to love, is this and love equal? Yes, in terms of value, both are equal because you assign. In terms of address location, both are equal. Yes, because it will not create a new object. You see here. So that's what happens. Now I'm saying like, hey, so love, this is love. True. This is love, right? Yes. So if I say like, this is operation is something like it will check object level. So equal to is different, is different. If I say equal to, both are same in terms of object or not. But if I say like, this is, for not equal to, you do like not equal to love, right? Similarly, so we have this is love. For this is, you do like, this every time till now, For anything to negate, you write like this, right? Not is love. So, but it actually falls. For the first time, you will feel something interesting because so in Python, they told like, it is not like a pure English, right? In a pure English, will you say not is or is not? You write is not. So to facilitate that, only for the is operator, you need to write like a is not. Only for the is operator, if you want to negate, you need to do is not. This is one thing you need to be aware. This is the one unique operator like this. So based upon that, he did something. So he said like, so this is love or this is love. Love is love. So love is not true or false. So like that, he did all these things. Now if I say, so this is love, true. This is love, true. So love is love. Love is not love. Like that he created. So like this. Now, lastly, if I go based upon these concepts, the last thing that we'll discuss today is on the bitwise operations. So what are the bitwise operations? Why we need it? Same like what we have done till now. This is one thing we have. To be frank, like I seldom used it. I think I never used in practical purpose the bitwise operations. So means bitwise, the name itself is saying like bit by bit operations, means at the binary level operations. First, I will tell what is this operation. I think like many languages support these operations. Let me show you. What are the operators traditionally are used? Instead of an end, they are using for this binary ends, binary or, binary XOR, binary plus, like that. So quickly to walk it. For any number, we can represent in a binary form, right? I will show you that. With that, you will understand. If I have a number, generally binary format means to the powers of 2. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like that it will go on. If I take any number, I need to represent like this. Say, if I am taking the example of say 60, if I need to represent, if any number is greater than that, I represent with a 0. If it is less than that, I represent like this. 64 means greater than, right? So I represent 0. 32, yes. So 64 minus 32, you get some value. Then you represent. So you represent. So means till 8. Still you have like 4. So like that, you represent 60 with these things. Means if I add these values together, I should get the same number again. Wherever ones are there, say 32, right? 32 plus 16 plus 8 plus 4. If I add, I will get again 60. Means a decimal number you are representing in binary form. In the same lines, if I say I have a small number called as 30. If things are greater than that, represent with a 0, 0, 0, less than that, 8. 13 minus 8 means what? You have like 3 and so 3 and 2, 5. So I represent with 4. 1 is remaining. So 8. So if I add these two together, I get the same number. Means if I place 8 plus 4 plus 1, I get again 13. So like that, I have these values together. So now based upon this, if I do some operation, so there is something called as ampersand for binary addition. Binary addition means bitwise operation happens. Here no carry forwards, nothing. Each bit level. You see the first two bits in that column, both are 0, 0. Both are 0, 0. You know, uh, so end operation till now what everything should be true. Bitwise means 0 and 1. So everything should be 1. So if one of them is 0 here, right? One of them is 0. So the result is 0. One of them is 0. Result is 0. Both are 1. Result is 1. Both are 1. Result is 1. Both are 0. One of them is 0. 0. So like that you get it. Now, if I combine the values at 0th positions of all, wherever 1 is there, if I combine those positions, I get it. means like this, means into 1 only. So where if I do like 8th position and 4th position, 8 plus 4, I get the same 12. So indirectly it is doing the same job. Means like if I wanna represent it, I can represent it like this. Okay, I have written like this. Okay, if I do the same operation, you will understand. So I represent two numbers, and if I want their binary formats, I represent. See, I have taken like 30 and 16, sorry, 30, 60 and 13, and I am printing them and I'm asking their binary numbers. 60 in binary format is this, 13 in binary format is this. Now, if I do a AND operation, hope you remember earlier we got this 12, right? The same 12 I will get if I do. So for the numbers, just I do operation. I need not worry about anything. Similarly, if I do the OR operation also same thing. How the OR operation works means in the same logic as we did here. So we need to work in the same way. OR pipe operation. OR means at least one of them should be true. So means at least one of them should be 1. So both are 0. At least one of them is 1. In this one and this one I'm saying. So here also at least one of them is 1. Both are 1. Both are 1. So both are 0. At least one is 1. So if I do all of them, so I get like 61. So similarly, if I go for the XR, this is bitwise XR. Bitwise XR means if the total number of ones is odd, it will be true, means 1, else it is false. So if both are 0, false. Both are 0, false. Total number is 1. Count of ones is 1, which is odd, so it will be true. So only 1, 1. 2 ones are there, so it will be even, so it is false. 2 ones, false. 0. Only 1, 1, it is true. So like that it will be. If I add right now the position set these two, 32, 16 and so, I get 49. So like that we can do all operations. So either you do AND operation, OR operation, XOR operation. So we can do get the same answers. If I do like this is XOR and this is like this is XOR and this is OR. You got the values. And in the same lines, you have complement also that you can try as a assignment. So complementing. So negating and adding 1 to it. And similarly, we have this concept of left and right shifts. So to understand this left and right shifts, I will tell you very simple logic. Okay. If I take any number and if I'm doing a shift, left shift by 1 position, the arrow is saying left means left shift, right means right shift. Observe very carefully. If I take a 10, I am doing left shift by 1 position, 2 position, 3 position, like that. For every position I'm shifting to the left, I'm getting what? Twice of the numbers. So that's what you need to understand. So how actually works in the backend? So there is one graph. With that you will clearly understand. So I created a graph of all of them together in one place. So I have taken these values in terms of binary position. First I took 10. 10 means like in binary format 1010. This, when you're doing a left shift, what's happening? The values will go to by 1 position. Means earlier one has a value of 8 and one has a value of 2. Now the same one is 16 and another one is 4. That's the reason when you add 16 plus 4, you get 20. And again you shift by 1 position. So like that, every time you shift left, you multiply by 2. Every time you shift by right, you divide by 2. So that's the reason if I do the same thing in a reverse direction. So finally I got 160, right? From that 160, I am doing in a reverse. If I am doing right shift by 1 position each, you get like, so 80, 40, so and so. Hope you understood what is this concept of left shift and right shift. So I'm making a note to you. For that you will understand. When you divide or add, so it will be with the powers of 2. Because it's a binary number. All operations will happen like this. Hope it's clear till now. So with this, I want to stop. And this is all about the binary operations.